this delete and new operator are used with dynamic memory allocation. This we have already seen in C, where we have the malloc, calloc and realloc functions, where at the time of programming only or during the time of execution only, the compiler will allocate the memory according to the variables that are needed for execution at that particular time. So, it is a waste if we are going to allocate memory for variables which are not going to be used during the program. Memory is a very it's not a resource that is just going to keep increasing. It is well within defined boundaries. So, we have to use the memory very efficiently. So, that is the reason we go in for this new and delete operator in C++. New operator allocates memory, delete operator frees the memory. So, how are we going to use these operators? When we request for dynamic memory, the new operator is used, and this is the syntax. The pointer variable is equal to new keyword and the data type, or pointer variable new keyword and the number of elements. So, this is an example for that. Integer is the pointer variable, integer pointer p is the pointer is equal to new, int is the data type and the number of elements. So, how is this going to be put in memory? You have the p variable pointing to the first block of the 5 number of elements that have been allocated. So, this is how it will be identified, new int of 5. So, you have 5 blocks of memory over here, 1, 2, 3, 4, 5. P is the integer variable and that points to the first block of that set of memory. So, this is how the new operator allocates memory in C++. Delete operator. Now, as I have already mentioned, dynamic memory is very much limited. So, it has to be efficiently used. When it is no longer needed, the memory needs to be freed. And to free the memory only, we use this delete operator. The syntax is very simple. Delete pointer, either just one pointer variable if it is there, and if that it is an array of pointers, we have to use the square brackets to represent the array. Now, the value which is passed is an argument to delete. Now, see, when you say delete, you should tell which memory has to be deleted or which pointer has to be deleted. The example programs that we are seeing have only 1 or 2 pointer variables. So, we just give delete and the pointer variable name. In big programming methodologies, we may have several pointer variables. So, when you give delete, you should specifically mention which pointer is to be deleted. So, there has to be an argument to the delete operator. The argument must either be a pointer to a memory block which is previously allocated with a, so that pointer should have been allocated by the new operator. It cannot just be any pointer, only when memory has been dynamically allocated, it can be dynamically released. Or it should be a null pointer. Null pointer indicates that there is no memory existing there because no memory was allocated. It is not necessary that when you give new, immediately the memory should be allocated. You do not know whether memory is available or not, because the program is just executing. So, the programmer does not have any idea of whether when he gave a new operator to allocate memory, whether memory was allocated or not, because memory is very less in number. We are giving new because we want the memory, but whether the computer is having the memory to give us or not, we are not aware. So, if new operator had failed in its execution, it will return a null pointer. If it had succeeded in its execution, it will have the pointer to a memory block. So, when we give the delete operator, it should either be a pointer to a block of memory previously allocated, or it should be a null pointer. If it is a null pointer, the compiler will understand that the new operator's execution did not succeed. So, it does not have any memory to free at the moment. So, the programmer needs to check whether the requested dynamic memory was allocated or not. He cannot take for granted that when new is given, memory is allocated. One is the concept of exception handling, which is a separate concept in C++, which we will be seeing later. The other is called the no throw method. No throw method is, in case the memory allocation fails, the pointer returned by the new is null pointer, and the program will just continue its execution. It will not affect the proceeding of the program in any way. See, we want a program to be like that. Just because new operator fails does not mean the entire program should crash. So, we want the compiler itself to make certain alternate arrangements in case the memory is not allocated. So, that is only done using this no throw method in C++. So, that is a use of this new and delete operator. So, when new is used over here, that means memory is allocated for this pointer variable pt, and immediately the constructor with 2 arguments is called. So, 23 will be allocated to the first number, 13 will be allocated to the second number. And in the next statement what we are doing is using the C2 object we are calling the add function. So what happens when the add function is called? The compiler will go to this add function, it will add the two numbers n1 and n2 and it will assign it to tot. So the n1 and n2, so tot will be carrying the result of the added sum. Next C2.disp, it will display the result. Then this is a pointer variable. We know that when we use a pointer variable we cannot have the dot operator. We have this arrow operator to access the members of the class. So using this pointer variable we are going to give pointer.add pointer disp. So this add function is going to add these two variables 23 and 13 and the display function will get the result. Now we will see the output. The output is all in this display function. So C2.disp and PT arrow mark disp. So this disp is going to display the added sum. In the case of C2 the numbers are 10 and 20. In the case of PT the numbers are 23 and 13. So the first result should be 30 and the next result should be 36. So whether the result is correct, the sum is 30 and the sum is 36. So this is how the pointer variable and a normal object can be used to access the members of a function. So we have seen constructor overloading, constructor with no parameters, with two parameters, and an object which is a pointer variable, how it is accessing the member functions of a class, and how the compiler tries to differentiate between the constructors and the member functions, and how to access the member functions if we are having a pointer variable. And when we use a pointer variable we have to allocate memory using the new and the delete operator. Here if you see, after the pointer variable's work is over, immediately we are giving delete PT. So these are the different types in which a normal function and a constructor function will be overloaded.